Oh no. I think this is not straight.
Recently I've been building quite a few things, using mostly my electric drill. And the one thing I noticed while doing that is that no matter how well and level you position everything, it still all depends on whether you can drive your drill completely straight into the wood. And as you can see, I suck at that, no matter whether I drill horizontal or straight above the wood. And yes, I know that there are more or less a bit imprecise gadgets out there that can help me with this problem. But I also got a whole workshop full of electronics, meaning there has to be something that should give me more accurate and useful results, right? So in this video, let's try to hack my electric drill in order to add an intuitive to use and precise kind of spirit level system, and ultimately do some testing to find out whether it can really improve my drill skills. Let's get started! This video is sponsored by Mauser Electronics, whose components are used for all sorts of projects. I've actually been ordering from them so much that there is an entire box of SMD components in my lab. And right now they are still doing a Halloween celebration and giveaway. So click the link below to enter and get a chance to win a AKX00066 Elvic robot, which is a versatile robot car for programming and robotics education. I wish you good luck, and don't forget to visit Mauser if you're ever in need of a specific electronics component. To get started, let's clarify that all we need to solve my problem is attaching a spirit level to my electric drill, because that of course exactly tells me when I hold it level. But since this mechanical solution is obviously not optimal, I instead looked through my sensor drawer and found this board based around the ATXL345 IC, which is an accelerometer IC. As the name would suggest, an accelerometer can basically measure how much it gets accelerated. In this case here, it can do that in all three axes. To better show off what I mean though, let's simply connect this sensor to an Arduino using the I2C interface and use this Arduino library from elektronikkiste.de to show off the basic functionality. Now as you can see, the X, Y and Z acceleration does alter depending on how I hold the sensor. And when I lay it flat on my workbench, then the Z axis is almost 1, while the X and Y one are almost 0. The reason is of course Earth's gravitational pull, which equals an acceleration of 9.81 meters per square second, aka 1g, and that 1g is the one from the z-axis output. So yeah, in this position of the board, only the z-axis notices the gravitational pull, but if we for example put the board on its side, then you can see that now the x-axis should be fully pulled on, and that is exactly what we see on the output. So by using these three values and doing a bit of coding, we can basically determine how the board is positioned in space, and that is pretty sweet, I would say. And in case you're wondering why these values are not exactly 0 or 1, then let me tell you that such sensor ICs always come with a bit of tolerance. But thankfully, the used Arduino library comes with a calibration sketch, which we can simply upload and then move the board around to find the biggest and smallest values for the X, Y and Z axis. After typing those in, we now got a calibrated board that delivers good enough precise values. And for my drill application, the sensor board will be mounted like this, meaning that when I hold it horizontal level, then we basically only care about the Z-axis angle, and when I hold it above the wood, then we care about the X and Y axis values. But before figuring out how to mount the sensor onto the drill, I first had to come up with a feedback system, that communicates to the user the position of the drill. And at first, I really wanted to use the haptic feedback system that I discovered in a previous video, and around whose main IC I also recently created a breakout board that seems to work just fine. So my initial idea was to put such a haptic feedback actuator into the handle of the drill and basically let it vibrate with a higher frequency when I'm far away from the level position and decrease this frequency as I get closer and closer to the level values. Only problem for me was that coding this exact example was not possible for me. No matter what I2C code I tried, the IC never did what I wanted it to do, and only by using a bit of example code given by the datasheet, I got this actuator to move a tiny bit. But from there, I was not able to successfully modify this code further, which once again proves that I'm bad at programming, and that such already existing Arduino libraries are awesome. So I had to scratch that idea, but that was no problem because I already had another, probably better one in mind. And to demonstrate that, I firstly had to 3D print a small fixture. On it, I mounted 4 LEDs along with the sensor board and wired that all up to an Arduino Nano. After then writing some clever code that basically uses the PWM function according to the board's position, you can see that the upper and lower LED now guide me to the horizontal level position, in which no LED lights up. And if we turn it around, just like when your drill is above the wood, then all 4 LEDs basically guide you to a completely straight position. In my opinion, this should hopefully do the trick to solve my problem. Meaning, next I had to open up my drill to find out where to house the electronics. And yes, this thing is not only really dirty because I never opened it up before, but it also seems like there is not really any space available. I mean, yes, there is some in the handle, but honestly speaking, I touch pretty much all parts of this drill while using it, and thus positioning electronics on there that I have to be able to see is not a good idea. So next, I thought, why not simply place the electronics on the battery? I mean, I got 2 promising looking screws here. So I spent a bit of time to come up with a fitting enclosure in Fusion 360 and then 3D printed that with some PLA filament. The results looked pretty promising and also fit perfectly, because this was honestly my 3rd attempt. Inside we should hopefully have enough space for all the electronics, except of course the big Arduino board I used so far. As an alternative for that, I got myself an ATtiny 804 from Mauser Electronics, which I pretty much only have to solder to a breakout board to use it. What I love about these ATtinys is that they are super cheap and you can easily program them using the Arduino IDE and the Mega Tiny Core by using a modified Arduino Nano. So I removed the Arduino Nano from the fixture example, hooked up the ATtiny, changed the code a bit by simply using other pins and limiting the max PWM value to 100, then uploaded that, and there we go, everything still worked perfectly fine. And the great news here is that we can lower the supply voltage down to 3 volts, meaning I will be powering my system with a small button cell that should have enough capacity to power the system for quite a while. And the last big thing we have to address before assembly is that my drill head here is not level with the enclosure, aka the sensor boards. That means I had to read out the offset values when the z-axis was level, which was at around -3, and when the x-axis was level, which was at around 3. By adding those offsets in the code, it was finally time for assembly. And let me tell you that this was not hard to do, just a bit tedious because of all the wires. And if you're interested in trying something like this out yourself, then you can find all information in the video description. With that being said, my drill add-on was complete, and it was time for some proper testing. After doing a couple of holes and trying some things out, I gotta say that this thing is really useful. I mean, you have to keep in mind that it is only accurate while positioning, because as soon as the drill starts, we accelerate the boards and get wrong values. But by going slow and doing breaks, you can really do some precise work here, especially when it comes to the top-down mode. When doing the horizontal level mode though, it can be a bit irritating that you have to look at the battery and the drill head at the same time, and thus this mode takes a bit more practice, but can still deliver really good results. So yeah, overall not bad, and I'm surprised that I have not yet seen such a gadget on AliExpress or similar. But what do you think? Is such a modification worth it, or should I just get good? As always, thanks for watching. If you enjoyed it, then don't forget to like, share, subscribe and hit the notification bell. Stay creative, and I will see you next time.